Hello everyone, Professor Dustin here, and this video is going to be about a solution to the dungeon escape whiteboard. So in this whiteboard, the situation is we have escaped from your cell in a dungeon right here underneath the castle. If you can run through the tunnel and find an exit on the other side of the river, which is 205 meters away, and the river is 30 meters wide, you can escape from the evil wizard. So then there's some instructions on how you are going to travel, which I'm just going to draw into the picture. First, you take a tunnel 150 meters long, traveling 37 degrees north of east. So if I draw a little coordinate system right here, that's supposed to indicate x and y. And north, as shown by this little compass right here, is straight up. Then north of east will be an angle like that. And I travel a distance 150 meters. I'm going to call that vector A. Say its magnitude is 150. And this angle is going to be theta A, and call that 37. So the next instruction says I make a right angle turn to the left and travel another 200 meters. So a right angle turn in this situation means that that angle right there is 90, and then I go another 200 meters. And based on my picture, it does indeed look like I'm going to get to the other side. So I'm going to give that vector the name B as a magnitude of 200 meters. And I've got an angle of 90 degrees right there. Now at the end of this tunnel, I see a hatch in the ceiling, and I want to know if I've gotten to the other side of the river. So basically, is my drawing to scale? I didn't try to make it to scale, but is it actually to scale? So the first problem I see is that, okay, I could maybe figure out anything I wanted to know about this vector because I have an angle and a distance. I could like find its x and y components. But for B, I can't really do that because I know that angle is 90, but in this coordinate system, I don't know what any of the angles there are. But I do have an advantage where I have a horizontal line here, so I can draw a horizontal line up here. And now because a line cutting through two parallel lines gives complementary angles, I know this guy right there, that's 37 degrees, which means that I know this is 90 minus 37, which means that is 53 degrees, and I'm going to call that theta B. Okay, so now I've got all the problems set up, and the question is, I have two vectors, vector A, vector B, and the vector which represents my actual displacement afterwards, which is right there. Let's call that vector C. And I can form a vector equation because these vectors are added head to tail. My vector equation is C is A plus B. So that means that I have two equations. Cx is Ax plus Bx. Cy is Ay plus By. So to answer this question about what the vector represented by those two components is, I just need to figure out what the components Ax, Bx, Ay, and By are. Well, I've got my triangles drawn over here, so that's going to be pretty easy. Here's my A triangle, so I have my Ax right there, and Ay right there. So that's, and I can get what those are going to be just by using trig. So this is going to be A cosine theta A and A sine theta A. For the Bx and By, I can draw those guys in. By will be right there. Bx will be right there. And I have B cosine theta B for the x direction and B sine theta B for the y direction. And again, I should check my directions. Ax is positive, Ay is positive, By is positive, but By should be negative. So I'm just going to put a negative sign on that. Sorry, Bx should be negative. Put a negative sign on that guy. Okay, so I'm just going to go through and calculate each one of those things. So 150 cosine 37 is 120 meters. 150 sine 37 is 90.3 meters. For the components of B, 200 cosine 53 is 120 meters. and 200 sine 53 will be 159. Actually, it's more like 160. So now I just take those components, plug them up here, and I get the components of my resulting vector cx and cy. So I can just about do this in my head. Just make sure you remember the negative sign, which I forgot right there. And so then cx is the sum of ax plus bx, that's 0 in this case, and cy is the sum of ay plus by, which is 160 plus 90, that's about 250 meters. I could write that as a unit vector if I wanted, in terms of unit vectors rather, and it's simply 250 meters in the y-hat direction. But of course, all I need to do is, in the y-hat direction, I need to get 205 plus 30, that's 235. So this is 250 is more than 235, so I make it out of the dungeon. So some of you might have done this problem by simply looking at just the y direction or doing some other kind of triangle geometry, and that's all fine. But I will just point out that doing this, setting up the vector addition and then splitting into x and y components, will always get you the right answer. You have to be careful going through these things, but sometimes triangle geometry is just going to be too hard, or you're not going to see the simple relationship that you need for triangle geometry, whereas this one will get it. No matter what kind of complicated vector addition you have, you'll always get the right answer. So I would advocate doing this way, splitting into components, when doing any kind of these vector problems. Okay, thank you for watching. See you soon.